So there's my 5 questions, and every time when I get to the end of it, what this means is we work out, whoops, didn't mean to cross it out. We work out a proper scale for X when we're done our 5 key questions and make sure that it matches, and then we just go ahead and plot our points. Okay, so we're going to graph one cycle of each of the following. Question number 1 is the zero line, which is, in other words, the vertical shift, the shift up or down, which there isn't one because this is just plus 0. D is 0, so y equals 0. Question 2, the amplitude is 2 over 3. That's my A value. And then I use that to come up with my max, which is the 0 line, in this case 0 plus 2 over 3. So that's 2 over 3. And the 0 line minus the amplitude, so negative 2 over 3. And it seems like, 2 over 3, that's going to be hard to graph. No, not if we make our scale the right way. It's going to be super easy. You probably remember that from grade 11 as well. Question 3 is, where does it start? So again, normally it starts at 0. There's no phase shift here, or there's no horizontal shift or horizontal translation. So I don't really call it that, although the textbook does. It should be called a phase shift. But there isn't one here, so it's just 0. 4 is the period. So here's where we have to do a little bit of math, and that's equal to 2 pi divided by my k value, which is 3 over 2. And so that works out to 2 pi times 2 over 3. So that's 4 pi over 3. And then my stop, question 5, is the start plus the period. So in this case, it's just simple. It's 4 pi over 3. But now what I want to do is I'm going to think about where my critical points are going to be. So like how many degrees or radians in this case they're going to be separated by. So I take my period, 4 pi by 3, and divide that by 4, which works out to just 1 pi by 3. Right? 4 pi by 12 or 1 pi by 3. And here's where I think you can kind of cheat. Like, you can probably make your scale now. Like you can probably sort of figure it out and make it work without doing any more math by just counting squares. It's not really cheating, but it's kind of like the easy way of doing it, because otherwise it can get a little bit messy. Or you could choose, this is how I would do it with degrees, but with radians it just gets a little bit messy. So I'm going to choose my X scale by taking my critical points and dividing that by 3, which gives me pi by 9. But I'm not sure that I want to worry about the pi by 9 part. You're going to see what I mean by this in a minute. But what it's telling me is it'll take 3 squares to get to my critical points because I divided that by 3. Right? That's what it's telling me. That's something that's important to think about. How many squares between your critical points? I would say we almost always can make it, I would say aim for 3, but if that's not working for some reason, you could go with 2 or you could go with 4. Both of those are nice. That means your graph isn't too big and it's not too small, and it'll almost always work with everything. Okay. The only thing, we talked about this before, the only thing you have to be a little bit careful of is that your phase shift, because of the way we calculated it, as long as it fits my phase shift, it'll fit everything else. Okay. So if I was if I was counting by pi by 3s and my phase shift was pi by 4, that wouldn't work because pi by 4 won't be a point in there. So then I would have to change my x scale. That's what I'm talking about. So that it matches both the critical points and the phase shift. But in this case, our phase shift is 0, so it's super easy. So then when I graph, I'm going to think about my 0 line, which is, this is sine. So my 0 line is just here, right? It's just the x-axis. There's no reflection. Oh, I'm gonna make my scale. So here we go. I'm counting 3 squares. Goes to pi by 3. 1, 2, 3 squares is 2 pi by 3. 1, 2, 3 squares is 3 pi by 3 or pi. 1, 2, 3 squares is 4 pi by 3. And this is what I'm talking about. We didn't even, we calculated pi by 9 as our square size, our x scale. So just watch for a minute. I think this is a valuable thing to go through. I think it helps you with fractions. So this is like 1 pi by 9, 2 pi by 9, 3 pi by 9, which is the same as pi by 3. 4 pi by 9, 5 pi by 9, 6 pi by 9, right? Like same thing. Like that's what we're counting by. But we don't even really need to worry about that because I've already got everything labeled and everything. So I start here. Oh, and I want this to be 1 and this to be -1. So I broke it up into thirds. So it's easy to find my points at 2/3, right? So my max is 2/3, and that occurs after 3 squares. For sine, I'm back onto the 0 line after 3 squares. At my min, whoops, that's wrong. Should be 2/3, right? My min is -2/3, and then back on. And I like this because I can see that matched my stop. Like when I counted it and I did everything, that's 4 pi by 3. That's where I was supposed to stop by what I calculated up here. And then when I counted out the squares, that happened too, right? So then draw my curve like that. And we talked about this the other day, but there's all these other patterns involved, right? So if you know where your start is and you know where your stop is, and as long as they're right, you could also plot those and then think about the halfway points and where the key points occur there, right? Like there's different ways to think about it, but it all should match. That's kind of also what I mean by you could cheat a little bit on the scale. But you do have to mark your scale. Like you can't just always put it in 12 squares and not include scale. Like a big part of this is putting our scale on. Any questions about that? All right, let's try another one. One thing we have to do before we graph this one, what do you have to do before you can graph this one? 2 people think they know, 3, 4 maybe. Sam, what do you think? Right. So when we have our transformations are always 3x something like that. Has to be like that, right? Your phase shift has to be factored. It has to be factored out. And so what does that work to? Pi by 3. Okay, I want you to try this one. Go. Okay, good. Most people are really like on, like in the right direction, almost there. But a couple of little tricky things. So there's my work. Let me go over it. If you want to put your pencil down and just watch, might be a good idea. Like a lot of people got to the end, and then we're like, I can't quite draw it. I got all the math done, but I don't really understand how to turn that into a picture. So let's go back over this. The zero line and the amplitude, the max min, that's all easy. The start, make sure you get negative pi by 3 there, right? The period is 2 pi by 3, so I take 2 pi and divide it by 3, and that gives me 2 pi by 3, obviously. And then the stop is negative pi by 3 plus 2 pi, which is positive pi by 3. Good. That part's, I think, the easy part. Most people got that and are good there. Now what do I do to make my x scale and figure out where to put my points and that kind of thing? Okay, so I took my period and divided that by 4. You don't divide the stop by 4. In the first question, it might have looked like that, but that's because the period and the stop were the same. But it's the period that we divide by 4. Why do we do that? Because look, there's where I start, and then I've got 1, 2, 3, 4 equal distances that add up to my period, right? So I take my whole period and divide it into 4 equal parts. What's that telling me? I know where I start and I know where I stop, but I don't know where these points are supposed to be. So this is what I'm saying. Like, you could just plot those. You could just say, well, I'm starting at 0. I'm going to count 12 squares, and I'm going to call it 4 pi by 3, and then I'm just going to split that up into 4 parts. But you wouldn't, would you be able to label those properly? That's all we're doing, is thinking about how we're breaking that up into parts. So we're just making sure that all the fractions kind of match. So I take my period and divide by 4. I do the fraction math. That's happening behind closed doors. But what's happening there is, like in this case, is 2 pi over 3 times 1 over 4. And that 2 and that 4. So that ends up with pi times 1, which is pi, and 3 times 2, which is 6, right? That's what I did to get pi by 6. Okay, and then I take that, and here's where I do my x scale. So I thought about this. I could do 3 squares. Every 3 squares divide by 3. That would give me pi by 18. But then you look at pi by 18, you're like, I don't know what that means. I don't know what I'm supposed to do with the pi by 18. Don't nothing. Don't overthink it. Okay? This is going to work. Because my start is pi by 3, that's fine. I can plot pi by 3 easily. Okay? And if you're working in pencil, if you're not sure about this, try it. And if it doesn't work, like if your next point doesn't fit on the scale, then erase it and try a different one. Like, you don't necessarily have to do it using this math. But try it a few times. Once you've tried it a few times, then all of a sudden it'll probably click. So I tried dividing by 3 and dividing by 2 just to look at the difference. I'm going to go with 3. I tried 2 earlier when I was working this stuff out, and they both work, but I like 3. It just spreads the graph out a little bit more. So what does that mean? It means every 3 squares is going to be a pi by 6. So 1, 2, 3 squares, that's negative pi by 6. And then 1, 2, 3 squares is negative 2 pi by 6, which is also negative pi by 3. Right? So there's my phase shift. So I know this is going to work. Oh, this is the wrong grid. Oh, I'm just going to have to scrunch my graph. That's okay. Does everybody get that? So where's the pi by 18? This is what I was saying before. Like, it's not a big deal. Don't overthink this. But I think it's not a bad idea to count it after you've done this. But where's the pi by 18? It's right here. 1 pi by 18, 2 pi by 18, 3 pi by 18, which is pi by 6, 4, 5, 6 pi by 18, which is pi by 3, right? That's where the pi by 18 is. Every 1 square is pi by 18. I think it's not as obvious when we're counting radians with fractions. If you were doing this in degrees, it would click a little bit more. Okay, and then I'm going to count over here. This is pi by 6, and this is 1, 2, 3, pi by 3, which is where I stop. So I'm going to have to scrunch my my y-axis a little bit. That's okay. So I'm going to go 1, 2, 3, 4. I'll call this 4. 1, 2, 3, 4. Call this negative 4. So I start at my min of negative 1. Because this is cosine, but it's reflected because it was negative 2 cos. Okay, count 3 squares, and I'm on the 0 line, which is 1. 3 more squares, and I'm at 3. 3 more squares on the 0 line. 3 more squares at my stop. Any questions about that? So make sure you divide your period by 4. If you have to convert these things into degrees, maybe just do that. What is pi by 18 as a degree? 10 degrees. And what is pi by 6? 30. And what's pi by 12? 15. 10 and 15 are both factors of 30. That's why they work. That's what we're talking about. So see how, now you can probably see it. I'm sure you can. This is why every 2 squares will take me to 30. This is why every 3 squares will take me to 30, where my critical points occur. That's what you're calculating. If you have to think about it in degrees, do that, absolutely, right? That's all we were doing. But you can kind of fake it, because we're just counting squares, and as long as your phase shift, as long as you can graph your phase shift, and you divided your period by 4, the other ones are going to work. Okay, one more. So give this one a try as well. I'm going to let you try it on your own. think the bell's going to ring in a couple minutes, but here is my finished route. A lot of people got here. This is good. So one thing that I talked to a few people about is, let's go back and think about all of these again. My pi by 4 that I kind of just did the math, I ended up with pi by 4, but I have no idea what that means. That's where everybody's at. Like, I get my pi by 4, but I don't know what to do with it. So maybe for now, especially, convert it to degrees and think about this. Pi by 4 is 45 degrees. My start is, so that's, I'm going to be counting every one square will be a 45 degree, right? That's what we're doing here. That's what we mean by x scale. My x scale is counting by 45. But I'm going to maybe mark every 3 or even every 4 of them. So I could only mark at 180 degrees, 360 if you want. Like, it doesn't matter where you actually mark them. My pi by 2, my start is 90. So 45, 90. That's going to work. It's going to be one of those points. It's going to be the second one. Counting from my axis is going to go right here. And then I count every 3 squares, because I divided by 3 is going to be another one of my critical points, which happens every 135 degrees. That's not as helpful. So it's going to look something like this. There's my 0 line. I'm going to count 2 and start there. And then, like, I go 1, 2, 3, bam, 1, 2, 3, bam, 1, 2, 3, bam, 1, 2, 3, bam. And when I do my scale, I'm going to find that that's 7 pi by 2. Okay. Oh, we didn't get to the word problem. There was a whole nother problem that we didn't get to. That's okay.